Welcome to my channel everyone. Here is a problem and this solution will give you some pleasure to all of you when you see this solution. Okay, now here is the problem is that for a fixed positive integer n, if this is d and determine factorial n plus 1, factorial n plus 2, and the second row is factorial n plus 1, factorial n plus 2, factorial n plus 3, and the third row is factorial n plus 2, factorial n plus 3, factorial n plus 4, and so that within the second bracket d by factorial n minus 4, and second bracket is closed, is divisible by n. Okay, so see, first simplify the given determinant, that is d. First we can write factorial n, copy the question here. Okay, this is factorial n and it can be expanded by n plus 1 into factorial n, then n plus 2, n plus 1, this is also factorial n, same as there is n plus 1. Okay, so n plus 2 into factorial n plus 1, n plus 3 into n plus 2 into n plus 1 factorial, same as n plus 2 here. So this is your n plus 3 and factorial n plus 2, n plus 4, n plus 3 and factorial n plus 2. Okay, take count factorial n from first row and factorial n plus 1 from the second row, factorial n plus 2 from the third row. Then we have 1, this is your n plus 1, this is your n plus 2, this is your 1, this is your n plus 2, this is your n plus 3. Okay, and the other factor is here n plus 1, and also the other factor here is n plus 2, same as 1, n plus 3, and the other factor to here n plus 4 into n plus 3. Okay, so see, here is a 1 in the column, first column, so we fix the row and taking factorial n from first row, factorial n plus 1 from second row, and factorial n plus 2 from third row. Okay, so see, factorial n, factorial n, factorial n. Okay, so here is n plus 1, here is n plus 2 and n plus 1. Okay, n plus 1 factorial, n plus 2 into n plus 1 factorial. Okay, now 1, n plus 1, n plus 2 into n plus 1. Doing this minus this is 0, so here is 1, this minus this, that is n plus 2, and this minus this, that is 2. Okay, then this minus second column minus second row minus third row minus second row. So this is here 1 and take common is n plus 3, then this minus this. Okay, so row 2 dashed is equal to row 2 minus row 1, same as row 3 dash is equal to row 3 minus row 2. Now expand. This is factorial n whole cube, n plus 2 and n plus 1. If we expand this, so this is 2 times of 2n plus 6 minus 2n. This is n cube, n plus 2. This is your n plus 1 whole square. So n plus 1 whole square. See, this is 2. This is only 2. Now, this is the figure here. B by factorial n whole cube minus 4. D means this is the figure. This is 2 into factorial n whole cube. This is here n plus 2, n plus 1 whole square by whole cube, and this is minus 4. Now simplify. These two are cancelled, so therefore d by factorial n cube, dy over factorial n cube minus 4, and the figure is here. We got 2, take common 2 here, so this is here n square 2n plus 1 and n plus 2 minus 2. This is 2 n to the power 3 plus 2n square plus n plus 2n square plus 4n plus 2 minus 2. So 2 are cancelled. So therefore 2 into, we take common n here. So n cube means n square, and this is here 4n square. So this is here 4n square. So this is here 4n n five n. This is here 5. So it is exactly divisible by n. Question is that this is divisible n, and it is follows that. Okay, so shows that hence this is the result. Hence this is the okay.